provided below, sketch the titration curve that results when a total of 40 milliliters of 0.2 molar HCl is added dropwise to the 30 milliliter volume of 0.10 NH3 aqueous. So the first thing you do is find out where the titration curve starts at. So at the start of the titration curve, there's 0 milliliters of HCl added. So you have 0.1 molar of NH3 and 30 milliliters of this. So then what you use is you say that you use the Kb constant. Kb is equal to x squared, the concentration of the OH ion, over 0.1 molar minus x. And since the Kb constant 1.8 times 10 to the power of negative 5 is a lot smaller than 1, you can assume that the 5% rule applies here. Even though you would have to show the 5% rule in an AP question, you can assume that applies here and get rid of the x. So it would be 0.1 times 1.8 times 10 to the power of negative 5 equals x squared, and you take the square root of that, and then the answer would be 0.1 times 10 times 1.8 times 10 to the power of negative 5, and then you would take the square root of that, and you would get x equals 0.001341. So that's the concentration of the OH ions that are formed by this reaction, that exist in the reaction, or the concentration of, yeah. So then after that, you would take the negative log of that to get, according to here, you would take the negative log of that to get a POH. So 0.001341 molar, which would equal, so negative, for the answer, 2.872. And then you would 14 minus 2.872, according to this equation right here, would give you the pH. So 14 minus that would get you around 11.127 pH. So that would be starting around here. Next, you need to find where the equivalence point is, how much milliliters of HCl you need to add to get to that point. So there's another, as you saw in the previous part A, there's another way to write the equation, which would be NH3 plus HCl to NH4 plus HCl minus. So then what you would do was you would take the 0.1 molar, and this is 0.2 molar of 0.2 molar HCl, 0.1 molar of NH3, and it says here that there's a total of 40 milliliters added, but you don't know how much you actually have to add to get the equivalence point. But you know that there's 30 milliliters of NH3. So to do this, you would do 30. So you would do the M1 V1 equals M2 V2 equation, and you would get 30 milliliters, and you don't have to change it to liters for the volumes, and 0.1 molar, because they're the same ratio. So 0.2 molar times V2, and you need to find V2. V2 is equal to 30 times 0.1 divided by 0.2, and that's 15 milliliters. So the titration is at, the equivalence point is at 15 milliliters of HCl added. Next, you need to find the total amount of the pH at the equivalence point. So NH3. To do this, you can use another equation where you have NH3 plus H2O is equal to H3O, because it's a strong acid. Plus is equal to NH4 plus H2O. And then you take the amount of moles of NH3 at the equivalence point, which is 30 times 30 liters, 0.03 liters times 0.1 molar, and then the H3O plus, or the HCl, is 0.2 molars at 15 milliliters, or 0.015 liters. So 0.015 times 0.2 is 0.03 moles. You want to find the moles of each so that you can find out which is the limiting reactant. And you realize that they're the same, they have the same amount of moles, so then they form both of these get canceled out, and you get 0.03003 moles of NH4, and H2O doesn't matter. So then after that, you use an ice table and you flip the equation. So NH4 plus H2O, and it's at equilibrium, NH3 plus H3O plus. So you know that H3O doesn't matter. So NH4 plus is at 0.03 moles, evidence below. And then since the total volume is not 30 milliliters, but 30 milliliters plus 15 milliliters, or 0.045 liters, or 45 milliliters. So you divide that to get the actual concentration, which is 0.067 mole. And then you need to find the NH3. You need to find NH3. Use an ice table. The concentration of H3O plus, which is a strong acid. This starts at 0, and subtract X here. You add X here, and then the total is 0 at the equilibrium. And this is equal to the Ka constant. So to find the Ka constant, you need to use this equation. Kw is equal to 1.0 times 10 to the power of negative 14, which is equal to Ka times Kb. And Kb is 1.8 times 10 to the power of negative 5, and times Ka is equal to 1.0 times 10 to the power of negative 14. So you divide that to get Ka, which is, and this works because they're both, this is at 25 degrees Celsius here. So 1.8 times 10 to the power of, so 1 times 10 to the power of negative 14 divided by 1.8 times 10 to the power of negative 5 is 5.5 times 10 to the power of negative 10. And you just you plug that into the equilibrium Ka equation, which is this X, the products over the reactants, but H2O doesn't count. So X squared over 0.067 minus X. Again, the 5% rule, and this is really a lot smaller than 1. It means that you can disregard this X. So it's 0.067 because X probably won't have an effect on the denominator. So equals X squared, and you take the square root of both sides, and X is equal to 0.067 times 5.5 times the answer, which is this, and you take the square root of that. Okay. Square root of the answer, which is 0.000. So 6.101 times 10 to the power of negative 6. And then you take to find the pH, this is the P, this is the Ka, so to find this is the concentration of the H3O plus. To find the pH, you need to take the negative log of that. And that would equal negative log of that, 5.214 at the equivalence point. So 5.214 pH at the equivalence point. And you would get, so it would start from here. The equivalence point is at 15 milliliters, and it would be around 5. So you have a straight line, almost a vertical line for both the around the equivalence point, and then it would start at 11 and go down to around 1 pH or 2 pH. So this would be what the titration curve looks like. Let's check it with the answer. Here you can see that the titration curve is pretty similar, and then you see if you get the points. First point, initial pH must be greater than 7. It's at 11, and this is at 11, so we get the first point. Second point, equivalence point is equal to 15 milliliters. Yep, so we get the second point. And third point, pH at the equivalence point must be less than 7, around 5, and we get the third point. So that's it.